Right, okay guys, I'm going to look through ionic bonding today. So I'm just going to pop here, ionic bonding. I've got a periodic table on the screen as well. I'm going to tell you why that's important in a second. When we're talking about ionic bonding, we're talking about when a metal reacts with a non-metal. So when a metal and a non-metal bond together, okay? I'm going to just show you where they are on the periodic table. So we've got our metals to the underneath and to the left of the staircase. So we've got our metals on this side. And we've got our non-metals on this side. Okay. So if you get an exam question and it says, for example, explain what happens when lithium reacts with fluorine. You then need to have a little look to see where lithium is. Well, lithium's here on the periodic table and fluorine's here on the periodic table. So we know we're talking about a metal and a non-metal, so that we know it's therefore talking about ionic bonding. And there's a couple of things you then have to start thinking about. So let's go with that example for now. I'm just going to split my page into two because I want to talk about the metals first and then I will talk about the non-metal. So let's have a little look at lithium. Lithium is a metal. I'm going to just draw the symbol for lithium here a little bit bigger so you can see what we're talking about. We're talking about a bottom number of 3 and a top number of 7. So let's just break down what those two things, well, certainly what the bottom number means for now. So lithium having a bottom number of 3 means that it's got 3 electrons and 3 protons. So it means it's got 3 positives in the nucleus and it's got 3 negatives on 3 positive protons in the nucleus and 3 negative electrons around the outside. So in total, lithium is an atom that has no overall charge. Because if you take a plus 3 and you take away 3, you've got 0 charge. I'm just going to draw what lithium looks like as an atom. So we've got lithium as an atom. We've got 3 electrons. So we've got 2 electrons on the first shell and we've got 1 electron on the outer shell. Now remember, everything wants to react. Any element reacts to achieve a full outer shell. And metals do that by losing their outer shell electron. So let's just write that down now so that I can remember that. So all metals lose their outer shell electron to become a positive ion. Right, so let's draw lithium again, this time as an ion. So lithium is a metal. It has 2 electrons on its inner shell, and we've just said that it's going to lose this 1 electron here, this outer shell electron, so that its next shell, the shell closest to the nucleus, is now full. So this is going to be lost. This electron here, this outer shell electron, is going to be lost. If it's going to be lost, so let's have a look at this bottom one here. We have now got in this ion, we have now got 3 protons in the nucleus. So we've not changed those at all. So we've got a 3 plus. So I'm going to put here 3 plus. But now we've got 2 electrons because we've lost one of our electrons. So we've got 3 plus, but now we've got 2 minus. If you have got 3 positives and you take away 2 of them, you are left with just a 1 positive. So we call this now a 1 positive ion. Okay, this is called a 1 positive ion. let's now have a little look at what the non-metals do. Okay, so let's get our fluorine atom as an example. So let's have a little look at the fluorine symbol of the non-metal, just like we did for the metal. So we've got 9 and we've got 19. This bottom number, this 9, means that we've got 9 protons and we've got 9 electrons. Okay, so we've got 9 positives and we've got 9 negatives. So overall, this atom has no overall charge. Overall charge is 0 on every atom. Okay, so we've got no overall charge because we've got the same number of protons as we have got electrons. So we've got no overall charge. Now remember, all elements react to achieve a full outer shell. Let's draw what this fluorine looks like. So we've got fluorine here. We've got 9 electrons. So we're going to put 2 of those electrons on the first shell. We're going to put the rest on this outer shell. So if we've had 9 and we've put 2 on the first shell, it means we've got 7 for the outer shell. So let's pop 7 on. So we've got 2, 7. Now, this outer shell needs to gain an electron for it to become full. So I'm going to put an electron on this outer shell here so that it becomes full. And I'm going to write down what the rule is for non-metals when they react. So all non-metals gain electrons to become negative ions in ionic bonding. Okay, so let's just have a little look at this now, okay? So we've got, I'm going to redraw this down here, okay? So we've got F with 2 electrons on it on the inside. We've got F now with 7 of its own electrons in it on its outer shell. And then we've got this 1 electron that we've gained. Now because of that, we've still got 9 protons. They've not changed at all. Okay, so we've got 9 positives. I'm going to put that over there. But now we've got 10 electrons. So we've got 10 negatives. If you have plus 9 and you take away 10, you are left with a minus 1. So this ion, this negative ion, has a charge of minus 1.